Today's lesson is called Upland Erosional Landforms. In previous lessons, we have looked at how glaciers form, move, and erode the landscape using processes like freeze-thaw weathering, plucking, and abrasion. Today, we are going to focus on the landforms these processes create in upland areas. Upland glacial landscapes are often dramatic. They include steep mountain hollows, sharp ridges, pointed peaks, deep valleys, and waterfalls. The big question for today is, how does ice sculpt mountain landscapes? By the end of the lesson, you should be able to explain how features such as corries, arêtes, pyramidal peaks, U-shaped valleys, truncated spurs, and hanging valleys are formed. Let's begin with the learning objectives. By the end of today's lesson, you will be able to explain the formation of landforms like corries and arêtes. You will be able to differentiate between V-shaped river valleys and U-shaped glacial valleys. You will be able to identify key glacial features on a landscape model or diagram. Finally, you will apply your knowledge of erosion to real-world upland topography. The key skill today is linking process to landform. A weak answer might say, the glacier made the valley bigger. A stronger answer explains how plucking, abrasion, freeze-thaw weathering, and glacier movement change the shape of the valley. Before we go further, let's go through today's key vocabulary. The first word is corrie. A corrie is a bowl-shaped hollow on a mountainside. It is often the place where a glacier begins. In different parts of the world, you may also see a corrie called a cirque or combe. The second word is arête. An arête is a sharp, knife-like ridge formed between two adjacent corries. It is created when erosion cuts back into the mountain from both sides. The third word is trough. A trough is a wide, flat-bottomed valley carved out by a glacier. It is often called a U-shaped valley because of its shape. The fourth word is topography. Topography means the arrangement of physical features in an area of land. This includes hills, valleys, slopes, ridges, and mountains. These words will help us describe upland glacial landscapes accurately. By the end of the lesson, you should be able to use these terms confidently in an exam-style explanation. Before we look at the landforms, we need to remember the processes. The slide describes glaciers as engines of destruction. That sounds dramatic, but it is useful because glaciers can completely transform landscapes over thousands of years. The first process is abrasion. Abrasion happens when rocks frozen into the base or sides of the glacier scrape against the bedrock. This acts like sandpaper, smoothing and scratching the rock surface. The second process is plucking. Plucking happens when meltwater at the base of the glacier enters cracks in the rock, refreezes, and attaches the rock to the glacier. As the glacier moves, it pulls blocks of rock away. The third process is freeze-thaw weathering. This happens when water enters cracks in the rock, freezes, expands, and eventually breaks the rock apart. This is especially important on exposed peaks and slopes above the glacier. These processes work together. Freeze-thaw weakens the rock. Plucking removes blocks. Abrasion smooths and deepens the landscape. That combination is what creates the landforms we are studying today. Let's ask a question. Which process is most like sandpaper? Here's answer. Abrasion. Here's another question. Which process pulls blocks of rock away? Here's answer. Plucking. Let's check your memory with 3 quick retrieval questions. Question 1. Which process involves rocks frozen in the ice grinding against the valley floor? Question 2. What is the specific type of physical weathering that shatters rock in cold climates? Question 3. When ice freezes onto rock and pulls it away as the glacier moves, what is this called? Write your answers now. Try to do this without looking back. Retrieval practice helps strengthen your memory. Let's check the answers. Question 1. Rocks frozen in the ice grinding against the valley floor is abrasion. Question 2. The physical weathering that shatters rock in cold climates is freeze-thaw weathering. Question 3. When ice freezes onto rock and pulls it away as the glacier moves, this is called plucking. These 3 processes are essential for explaining almost every erosional landform in today's lesson. Now let's look at our first upland erosional landform, the corrie. A corrie is a deep, bowl-shaped hollow found on a mountainside. It is often the birthplace of a glacier. Corries commonly form in sheltered hollows, especially on north-facing slopes in the northern hemisphere. Why north-facing? Because north-facing slopes receive less direct sunlight. so snow is more likely to survive from one year to the next. The formation begins when snow accumulates in a hollow. Over time, the snow is compressed into ice. As more ice builds up, it becomes heavy enough to move. In a corrie, the ice does not simply slide straight downhill. It often moves in a curved motion called rotational slip. This rotational movement helps erode the hollow. At the back of the corrie, freeze-thaw weathering weakens the rock, and plucking steepens the back wall by pulling blocks of rock away. On the corrie floor, abrasion deepens and smooths the hollow as rocks embedded in the ice grind against the bedrock. Over time, this creates a steep back wall, a deep hollow, and often a raised lip at the front. After the glacier melts, the hollow may fill with water, creating a small mountain lake called a tarn. So, a strong explanation of corrie formation should include accumulation, compaction into ice, rotational slip, plucking, abrasion, and sometimes the formation of a tarn after melting. Here's a model exam answer. A corrie forms when snow accumulates in a sheltered mountain hollow, compresses into ice, and moves by rotational slip. Plucking steepens the back wall while abrasion deepens the hollow, leaving a bowl-shaped depression that may later contain a tarn. Now we move from individual corries to the sharper landforms they can create. The first is an arête. An arête forms when two corries develop back-to-back or side-by-side. As each corrie grows, erosion cuts backwards into the mountain. Freeze-thaw weathering, plucking, and abrasion all help to steepen and deepen the hollows. Eventually, the land between the two corries becomes narrower and sharper. This creates a knife-edged ridge called an arête. A famous example in the UK is Striding Edge in the Lake District. The second landform is a pyramidal peak. A pyramidal peak forms when three or more corries erode into the same mountain from different sides. As the corries cut back, they leave behind a steep, pointed summit. The result is a sharp, triangular mountain peak. A famous example is the Matterhorn in the Alps, although similar features are also found in upland glaciated areas of Britain. The key idea is this. One corrie creates a bowl-shaped hollow. Two corries can create an arête. Three or more corries can create a pyramidal peak. Let's ask a question. What is the difference between an arête and a pyramidal peak? Here's a model answer. An arête is a sharp ridge formed between two corries, while a pyramidal peak is a pointed summit formed when three or more corries erode a mountain from different sides. Now let's check that understanding. Complete the sentence using the word bank. A blank is a bowl-shaped hollow. When two of these meet, they form a sharp ridge called an blank. If three or more meet, the result is a blank peak. The word bank is spur, corrie, arête, pyramidal, tarn, trough. Take 1 minute to fill in the gaps. Remember the sequence. One hollow, two ridges, three or more peaks. The correct sentence is, a corrie is a bowl-shaped hollow. When two of these meet, they form a sharp ridge called an arête. If three or more meet, the result is a pyramidal peak. This is a really useful sequence to remember. Corrie, arête, pyramidal peak. Now we are moving from high mountain landforms to valley landforms. The slide asks, how do you turn a gentle, winding stream valley into a massive, straight-sided canyon? Before glaciation, many upland valleys were shaped by rivers. Rivers create V-shaped valleys because they mainly erode downwards. They also flow around obstacles, creating winding valleys with interlocking spurs. Interlocking spurs are ridges of land that stick out alternately from each side of a river valley. When a glacier moves into this existing river valley, everything changes. A glacier is much larger, heavier, and more rigid than a river. It does not weave around spurs in the same way. Instead, it bulldozes through them. The glacier widens, deepens, and straightens the valley. So, a V-shaped valley can be transformed into a U-shaped glacial trough. Let's break down the transformation from V-shaped valley to U-shaped valley. Phase 1. Before glaciation, a river cuts a narrow V-shaped valley. The river mainly erodes vertically, cutting down into the landscape. Interlocking spurs form as the river winds around harder rock. Phase 2. During glaciation, a glacier fills the valley. Because the glacier is thick and heavy, it erodes both the valley floor and sides. Abrasion scrapes and smooths the valley floor. Plucking removes blocks of rock from the valley sides and floor. The glacier also cuts off the interlocking spurs because it is too powerful and rigid to flow around them. Phase 3. After the ice melts, a wide, deep, flat-bottomed valley is left behind. This is a U-shaped valley or glacial trough. It has steep sides, a wide floor, and a much straighter shape than the original river valley. Sometimes a misfit stream is found on the valley floor. This is a small river that now looks too small to have carved the huge valley it flows through. That is because the valley was not mainly created by the river. It was enlarged by the glacier. Let's ask a question. How is a U-shaped valley different from a V-shaped valley? Here's a model answer. A V-shaped valley is narrow with steep sides and is formed by river erosion, while a U-shaped valley is wider, deeper, and flatter at the bottom because it has been eroded by a glacier. Now let's look at two pieces of leftover evidence from valley glaciation. The first is a truncated spur. Before glaciation, rivers flow around interlocking spurs. But glaciers are much more powerful and rigid. When ice moves through a valley, it cuts off the ends of these spurs. The remaining blunt, cliff-like ends are called truncated spurs. The word truncated means cut short. So, a truncated spur is basically an interlocking spur that has been chopped off by glacial erosion. The second feature is a hanging valley. A hanging valley forms where a smaller tributary glacier once joined a larger main glacier. The main glacier was deeper and more powerful, so it eroded its valley much more deeply. The smaller side glacier did not erode as far down. After the ice melted, the smaller valley was left hanging above the main U-shaped valley. Today, streams flowing through hanging valleys often fall suddenly into the main valley, creating waterfalls. The slide gives Bridal Veil Fall in Yosemite as a classic example. These features are useful because they show how different amounts of glacial erosion happened in different parts of the landscape. Let's ask a question. Why does a hanging valley often have a waterfall? Here's a model answer. Because the smaller tributary glacier eroded less deeply than the main glacier, leaving its valley floor higher than the main trough. When a stream flows from it, it drops down as a waterfall. Now let's put the valley formation process in order. The four events are: a river creates a narrow V-shaped valley with interlocking spurs. Climate cools and a glacier begins to move down the existing river valley. The ice melts, revealing a wide, straight U-shaped trough. The power of the moving ice erodes and truncates the rocky spurs. Your task is to order these events from first to last. Take 1 minute. Think logically. River first, then ice, then erosion, then the landform left behind. The correct order is: first, a river creates a narrow V-shaped valley with interlocking spurs. Second, climate cools and a glacier begins to move down the existing river valley. Third, the power of the moving ice erodes and truncates the rocky spurs. Fourth, the ice melts, revealing a wide, straight U-shaped trough. This sequence is useful for exam answers because it helps you explain landform development step by step. Now we are going to apply today's knowledge to the British Isles. The question is, why are most U-shaped valleys and corries found in the north and west, places like Scotland, Wales, and the Lake District, rather than the southeast of England? There are several reasons. First, the north and west contain more upland areas. Higher altitude means colder temperatures, which helped snow survive and accumulate during the Quaternary. Second, the west receives more moisture from prevailing winds. Moist air from the Atlantic brings high rainfall and snowfall to western uplands. Third, during glacial periods, the north and west had thicker and more active ice, which was able to erode the landscape and form features like corries and U-shaped valleys. The southeast of England was generally less affected by thick glacial ice. It was more often a periglacial environment, meaning it was cold and near the ice, but did not have the same thickness of moving glacier ice needed to create major erosional landforms. So the distribution of glacial landforms depends on climate, altitude, snowfall, and ice thickness. You might have said, north and west uplands had lower temperatures, helping snow build up during the Quaternary. Prevailing winds brought more moisture to the west, increasing snowfall. The southeast remained more periglacial and lacked the thick moving ice needed to form major glacial landforms. That is a strong answer because it links location to process. It explains not just where the landforms are found, but why they are found there. To conclude, The jagged peaks and deep valleys we see today are the scars left by ice thousands of years ago. Corries show where glaciers began. Arêtes and pyramidal peaks show where erosion cut back into mountains from different sides. U-shaped valleys show where glaciers widened, deepened, and straightened old river valleys. Truncated spurs and hanging valleys are evidence of the power and uneven depth of glacial erosion. Even though most of Britain's glaciers are gone, their legacy remains in the landscape. The fun fact on the slide tells us that the weight of ice once pressed down on northern Britain. Since that ice has melted, the land is slowly rising back up. This is called isostatic rebound. So when we look at upland glacial landscapes, we are really looking at evidence of past climate, past ice movement, and long-term landscape change.